Hi and welcome to Analysing BGP Data with DAP.LIVE. I'm Katie and I'm the Project Manager at DNSRF. So today we're going to be discussing BGP and DAP.LIVE with our CTO, Mark Robertshaw. So Mark, what's BGP?
Great, well thank you Katie, it's nice to be with you today. We're going to start with a fairly familiar analogy. So many of you will be aware of how we send letters in life. So this picture here depicts how that works as a kind of flow. So on the bottom left hand side we've got our house where we live, and typically when we send a letter we'll most likely go and post it somewhere on our street, which you can see in the next picture up on the left. That will be collected by some sort of postman who will then take it typically to a sorting office in the city, which you would see at the top there. Now, as we all know, when you post letters somewhere else, different place entirely, there'll be some mechanism where that letter gets from our city to the other city, which you see on the right-hand side. And that's through the transit system. And then when it gets to the city, it then gets to a sorting office and then gets sent down to the street level where the postman will then deliver it to the house where you're going. That's how it works. Now, obviously, an extension of that might be that sometimes, as we know, in complex post systems, there's often more than one city involved. Quite often packages get routed around the world, and for convenience, there may well be more than one city involved in that process of delivering letters. That's a familiar example of how we would post a letter. And in fact, the internet works in a very similar way. So, in terms of how the internet works, as we know, things work on the internet via IP addresses. So every machine on the internet, every server, every client has an IP address. And on the left-hand side, again, we'll start with a client IP address, which could well be a web browser that we're using to access a web service. That will belong to an IP range, typically, which will be bigger than itself. So very much like the street metaphor, there'll be a range. You can see the range that I've given is a range that ends with /24, which means it's a range of 256 IP addresses, starting with the 82.0, which would then include the 82.83 that we have as our client IP address. Going bigger than that IP range has been assigned to what we call an autonomous system, and that has a number associated with it, in this case 15412, and that autonomous system may well operate many IP ranges of prefixes, but this is the one that actually maps to the range that we're in for our own IP address. And in exactly the same way as postage, our example before, the autonomous systems know how to communicate with each other. So it may well be that to get to a target, there may be one or more autonomous systems in the loop of routing to get to the target one, which is like the city analogy, is another big autonomous system where our server is hosted. And from there, that obviously has the prefix for our server. And as you can see at the bottom, the IP address for the target. So in order to get to our target from our client, we go via autonomous systems at the top and back down again to an IP address. And as you can see, BGP, or the Border Gateway Protocol, is the means of communication for autonomous systems to communicate with each other.
Thanks, Mark. So how do the autonomous networks get allocated the IP addresses?
Well, that's a really interesting question, Katie. And actually what happens is there are 5 regional internet registries who are responsible for assigning IP addresses, and they're geographically based. So there's one for Africa, one for North America, one for the Asia Pacific region, one for the Latin America region, and one for effectively Europe and Central Asia. And you can see there that those are the 5 registries, and they are responsible for designating IP addresses to autonomous systems within their regions of interest. And autonomous systems typically can be large organizations, large network providers, they might be big hosting companies, and they can apply to be allocated blocks of addresses, or prefixes as we often call them. And going a bit above that, the ultimate authority for assigning numbers is the IANA, which is the Internet Assigned Numbers Authority, and they are the ones that would actually delegate the actual IP addresses to the RIRs for further distribution.
So what BGP data do we have on DAP.LIVE, Mark, and where's it come from?
Great, Katie. Well, thanks for that question. I mean, actually, the way this picture is a really interesting picture because it depicts the kind of way in which BGP data is often detected. So one of the interesting things is that depending where you are on the internet, will often produce different results. And we mentioned before about that idea of routing, and where, when posting a letter, it might go through more than one city to get to its destination. And what's interesting is that depending where you are on the internet, it may be a different route to get to your target as compared to other parts. So here you might see, for example, that sort of pink cylinder I've depicted on a diagram there might be our target, where we're trying to get to the target sort of ASN or server. And you can see all the clients there as depicted as computers around the world. And the one that's very close might have a single hop to get to its destination. Ones at other parts in the world may have very different routes. So depending where you are on the internet may well produce different results. So what we often do is we use multiple observers around internet to look at what's happening with traffic to detect the routes that are in place for routing packets around, and therefore to get from one place to the next. And we actually use a project out of the University of Oregon, which is called Route Views, which gives us access to these viewers all around the globe. And we use about 5 or 6 different viewers distributed around the world to look at the data and determine how the routing is operating between ASN networks.
Great. So how can we use DAP.LIVE to analyse the data?
Great. So we've actually, having got the data from Route Views, which we do, we have 2 basic data sets that we're interested in here. We have the raw data set, which is literally the observed data we get from the viewers, which we have located around the globe. And we have summarized data, which gives us the unique prefixes as attached to ASNs, which we discussed earlier on. So to take a look at the sort of raw data initially, you can see here's an example of some data we've got back from a single viewer. You can see that on the end of the row is the viewer itself. That's one of the viewers we're using. That's based in the UAE actually, so in United Arab Emirates. You can also see that what we see for that viewer is the prefix that it's detecting, which in this case is one of the prefixes. And you can see that there is an AS path, which is the path that this viewer has to take through different autonomous systems to get to the target prefix that we see there. And the final number there, the 23969, is in fact the target ASN for the prefix of interest. Okay. Obviously, what we're more interested in often for summarization purposes is the unique sets of prefixes and their ASNs. So this data set, which is a summarized data set available in DAP.LIVE as a single data feed, gives us the unique sets of prefixes and ASNs which exist and have been detected via these BGP viewers. And you can see that we have both IPv4 and IPv6 addresses being detected through this BGP mechanism. We're going to focus today on IPv4 to keep it simple. You can see this data set gives us not only the ASN and the prefix information, but also a representation of the low and the high IP address for that range, which is helpful for us to calculate the size of ranges. And that's what we're going to do today, to look at the size of ranges and how which ASNs have the most IP addresses available, and which also how that breaks down by the RIRs, which delegate those IP addresses. So coming into the analysis of the system inside DAP, we're going to start by taking those IP low and high figures there and calculate the size of each range from those. So we start by creating what's a formula within DAP.LIVE, and here we simply would subtract the value for the high from the value for the low to give us a range size. And what that will do is create an additional column on the row that we're looking at before. And you can see we've now got a range size, and that gives us the size of each range. So it converts effectively the prefix, which has a sort of slash notation at the front. So in the first line says /24. That equates to 255 range size and gives us a sense of how big these IP ranges are. So moving forwards, we then want to summarize the data a bit more. We actually want to work out the total number of IP addresses per ASN, give us a summarization, and then we can sort of rank the ASNs by the largest ASNs for IP addresses that they manage. So here we have, using a simple summarization, we use the ASN as the summarize field, and we calculate the total number of IPs for each of those ASNs. And we get a data set that comes back very simple with an ASN with total number of IPs, and we can see that we've got the highest performing ASNs in terms of numbers of IPs they manage. Now, it's not particularly useful in this form because actually we don't know who they are. We can just see numbers, and that doesn't really give us much. The ASN number is useful, but not particularly descriptive. So what we can do within the DAP system is join another data set in, which is a list of ASNs that we obtain from each RIR daily, and we can then effectively find and look up the name of the ASN and join that in as extra data to our data set. So having done that, we would join based upon the ASN number, the ASN, which is the system number, across to our other sets, and we'd end up, we can then pull out both the name of the autonomous system as well as the RIR, which is being used to for that autonomous assignment. So coming back here, we get a much more useful set where we have both the RIR and the name of the autonomous system as well. And you can see that we've now got the top ranked ASNs, and you can see we've got a descriptive name against that, and we can see who the big players are at the moment in terms of IP addresses managed across the world. So it may be that we want to drill down even further from that and look at some bigger numbers. And one thing that might be of interest is to work out the total number of IPs managed by each RIR. And that can be simply achieved by further summarizing our data using the RIR data that came back from the previous join that we joined in to work out the total number of IP addresses managed by RIR. And you can see that we've got those numbers coming through here, where ARIN is the largest one, but you can see the breakdown now of the number of IP addresses managed per RIR. And finally, we might get a sort of sense of the global total of all of the IP addresses that we detected in the IPv4 space across all of the RIRs using the BGP viewer data that we have access to via root views. So again, we would apply another summarization finally, where we have no summarization, but simply add up all of the totals for every RIR and get a grand total. And we end up with a grand total here. And actually what's interesting is that we've detected just over 4 billion IP addresses, and actually the total number of possible IP addresses in the IPv4 space is 4.2 billion. So actually in this exercise we can see that we've actually got 94% coverage of all the possible IP addresses. So that gives you a sense of how you can use the DAP.LIVE system to analyse some BGP data to get some interesting metrics about how IP addresses are being used across the world and geographically distributed in the various RIRs and in total. Thank you for listening today.
Great, thanks Mark, and thank you for watching.